Hi, I'm Ransford, and I'll be facilitating this session today. And this session is powered by peer booking. So, peer booking is an on-campus support platform built by us to support people who are in need of academic, extracurricular, project support, and mentorship. And all these coaches and peer booking are actually students and people with the expertise in various fields that we find ourselves in. I'm very glad to have you here in today's session on understanding machine learning research methodologies. So I'm going to kind of kill two birds with one stone, right? So I'm going to look at open sourcing paper to repo, which is kind of a platform built to understand research methodologies. So to start, I would just look at the general research paper review pipeline. Then we will dive more into the specifics of methodologies. Then we look at the practical aspects where we dive into how paper to repo works. So I'm going to start with a very simple approach or method by Keshav. So I will share the link later to this paper, but it basically talks about the three pass methods used in reviewing papers. Okay, so the first one is the approach of skimming. So skimming a research paper is basically looking at the title, the abstract, the intro, the headings, and the conclusion. So this basically helps us to get the category, the context, and the gist behind the entire paper, right? So this kind of stimulates our interest in that particular paper. So skimming through a paper is like spending about 10 minutes just to understand the brief overview. For example, mostly what people do is the abstract to understand what the problem is, the solution, and how the solution solves the problem, and probably the future recommendations in there. And this kind of helps you to whether decide whether to read on or drop the paper. So that's the skimming. Then the second part is to grasp the content. So with this one, you read it with care instead of just skimming through, just reading through. You read it care, and then one thing I do is over there you skip proofs. You skip proofs. That means that you're not really going to look at maybe the various algorithms that have been implemented there. You're just looking at what is the content in there. What is the okay? We have a methodology. What methodology was used? What not necessarily how a certain algorithm was derived. So this is to help you understand the content. Then we have the last one, which is the virtual re-implementation. So basically rebuilding the work in your head, how the output should look like, how do you think they did the work. Okay, so and then I think how you can also what you can also do differently. So for the past three, you actually spend a lot of hours on it. Well, thanks be to like AI systems, technological tools. Now you can spend just less than 1 hour to understand people and trying to rebuild the methodology that they use. And so that's why we are here today. So normally this is the way that we understand papers. One, you just understand the title, you get the abstracts, the problem that has been solved in the paper, the solution, how it solves that, the output, the result that they got, and if there's any future recommendation, just to get appetite for whether read on or drop the paper. Then now you take your time to get your content from introduction, try to understand a brief literature review about it, trying to grasp the content of the methodology, what it entails, the entire pipeline, then the conclusion, the discussions, the result that they got, and at the end, maybe there are future recommendations. So over there, you can actually summarize the main thrust with evidence. Okay. Then now, last thing is to try and re-implement the method that they use in your head. Let me try and then, okay, I read a paper on segment anything by Meta. Meta, that is on Meta's current image segmentation model, segment anything. And so maybe I want to rebuild the entire pipeline. I want to also innovate in that field. So how do I do that? You try to re-implement that same methodology in your head, and then now what can I do differently? And so over there, that's when you reverse engineer the entire algorithms, the methodology. Okay, and this demands a lot of time. And so my concern will be much on that aspect, how you can fast solve that issue, how you can fast re-implement the methodology so as to speed the entire process of understanding a paper and also rebuilding or implementing something different, something so novel. Okay, so these are the three pass method that Keshav's talked about in his paper. So each pass leaves you with something concrete. So we have the first part, which gives you the 5 C's. So 5 C's I'm talking about here, the category, context, correctness, contributions, and clarity. So these 5 C's basically gives you the idea of whether the paper is worth an R, right? So it can just be a single paragraph verdict on whether the paper is worth an R. So, hey, which category is it falling in? Is it health tech? Is it medical AI? Is it agriculture? Is it materials? And then what context? Um, what's the evidence behind all the proofs, all the things that they are talking about? Um, what are the contributions that the paper is making in that context? And then how clear is the um, claims in that paper? So this is kind of a single proof as to tell whether what you're talking about, what that paper can be implemented or that paper is worth reading. Then the second pass gives you an idea of a brief summary, like an honest summary. So you can state the main claim, its evidence, and then a key figures to the key figures to someone else, right? So this is basically talking about what is the main idea of the paper. And then now, because you take this pass two is taking your time to grasp the content. So because you do that, you're able to get kind of the proof behind some of the claims that was made in abstract. Okay, so what is the evidence behind the claim that, okay, I was able to solve these particular issues that a lot of papers have not been able to solve? So you get evidence that, and then the figures, the key indicators to tell someone that, okay, yes, this evidence is right, and this is what they do, or this what I did. Okay, yeah, and also flag what you didn't follow. I mean, you definitely skip some things in, and so you're able to tell. It gives a summary of what you didn't follow, so that you can catch up when you are doing the reconstruction. So the pass three gives you an idea of the exact assumptions, and then the method rebuild step by step, and then a list of what you would challenge, change, or test next. So it's kind of if I were the one, what would I what would I have done so different to solve that particular issue? Okay, the existing architecture that they have, what can I do different? Can I make it better? Or they could have done something. Why did they do this? So there are a lot of challenges, there are a lot of things that you would want to recommend. And so you have to test what they've done, try and then also simulate what you're talking about and see the comparison between the two. And that's what we do at the pass three, like that's what the pass three reconstruction helps us to do. So I said that's where I'm really going to focus on in this session. Okay. Um, so the pass three tells us about 5 questions. It asks us about 5 questions. One, what exactly is the claim? Two, what baseline is it beating? Three, is the comparison fair in terms of data, compute, and then tuning? Four, which results breaks if the idea is wrong? And then 5, could I reproduce it as written? Good. So these are the questions that we asked of the past 3 helps us to do. And this helps us to, think of trying to do it to answer, to reconstruct the paper to answer these questions. Good. So that part 3 is really the methodology audit, and that's what you're talking about. So in the part 3, you really want to get uh, the entire algorithm, the entire architecture, entire approach, the strategy that they used. So you read much into the methodology. Okay. So one, the surface is that you look at the results, the tables, and then a polished narrative. So you look at the paper as presented, cleaned of its false start. So that's what you read. But then what you reconstruct is the method. So which baseline, which split, what was held fixed, how it was measured, and what was ablated. So the paper, when you are reading the content, you see that okay, there are results, they are getting this graph, okay, this one is performing best, this one is that. But what is the proof behind them? And that's through the method. And so that's what you're going to reconstruct and see if you get that same method. Okay, so um so if I'm getting this result, okay, probably, for example, if you have a paper in LLMs, like on LLMs, and then now they are saying ChatGPT is better than GPT is better than, let's say, Llama, right? Or let's say Sonnet plus Sonnet 5 or something. What shows? Have you tried? Have you experimented? What's their baseline model? What's the baseline architecture? You can even base on architecture. Okay, this one is using vision transformer. This is using this transformer. That means that per the default performance of the various architectures, this might be better than this, as they've already said. And that means the evidence is right, right? You can also try and implement the same architecture technically to check whether you're going to get similar results, or there might be something you have to change some nodes, you have to change some networks to make it better. How was the evaluation done? How was it measured? All these are things that you look at. And then the last thing is the verdict. The last thing is the verdict. What you judge, whether each choice was defensible and whether the claim actually follows from them. So I already talked about this. You basically reconstruct to understand or to prove that the claims or the evidences that you found in past 2 is right or not. Okay, so this is the methodology audit. When it comes to machine learning, this is even much deeper, because this is where you kind of um, meet very technical concepts, very technical claims, very technical evidence-based papers or systems or research. And that means that you need a very systematic approach to check whether that claim is right or not. And so you need a lot of ways to do that. And so mostly it's very hard, yeah, kind of a bit hard to understand technical papers as compared to maybe sociological papers or some things. Yes, so as part of my work, I'm looking at several different frameworks to help easily reconstruct this kind of algorithms, or even um, top up the knowledge that you already have. So before you can top up the technical knowledge, you need to understand the existing ones. And so I'm looking at various frameworks that helps with that. So there are 5 links between a question and a claim. Okay, so the first thing is the question. So first is a falsifiable ask. That is precise enough that a result could prove it wrong. Okay, so in the paper, they are saying that they could make a crab walk or something. So they developed a tool to help that, to help a crab to walk on bare land like human beings. You have to set a hypothesis that challenges the result, such that it's precise enough that a result could prove it wrong. That's one. Then two, data. So this is the evidence gathered without bias, provenance, and sampling documented. So um, we need to look at the data. Okay, what data did they use? What are the biases? What features are there? So you are proving why you got this result. Um, if there was this particular type of data, would it have gone better or gone wrong? Okay, if you introduce this particular bias, is what's going to happen. So even not to talk technical, even if you are doing maybe sociological stuff, research, or like social science research, you would definitely be looking at sample data, right? Maybe if you're looking at sustainability issues, flooding issues, how many people were affected. I mean, you probably be biased towards if you don't really look at the data, particular data represented in the methodology, you wouldn't really understand the result that they are getting, and even be able to pinpoint maybe there are some biases in there. So you have to prove, okay, based on this means the bias is low, and then the results might be good for other future works, right? Yeah. And the third one is design. Um, the fourth one is the measure, and then fifth one is the claim. So that these are the links. So before you get to from a question to a claim, to conclude that the result that they've got in a paper follows the evidence that they've reported in that paper, you need to look at the data, the design, and the measure. So the design is basically the baseline, the variable at a time, like comparing the various what's the name parameters that they've reported in there and the proofs behind them, whether they are right or not. Then the measure is to get a right metric with uncertainty. So, for example, if you report that there are 1,000 residents at maybe Ablekuma, and if Ablekuma is what's the name submerged in the water like flooded, and you're saying we fed 3,000 people, but there are only 1,000 people reported to have stayed in Ablekuma during that period. That means that there might be some wrong claims and stuff. So you need to check for the right metric. How do you get a right metric? You need to look at the design. What's are they basing on? What statistics are they basing on? Probably they are using 2022 data, but we are in 2026, so maybe there have been some changes. So it means that if you are moving forward, you can also replicate the same paper, same methodology, but then you are basing on what a very stronger baseline. And that makes your claims very more evidence-based. Yeah. So that these are the links between the questions, the past three questions, and then now getting to know whether the claims made are right or not. Okay. So now what to talk about is what are we looking at in terms of machine learning? So in terms of machine learning, we are looking at the data leakage, the split strategy, the compute fair baselines, and the seed variance. What I'm talking about here is that the difference between a normal paper like a sociological or social science paper, a machine learning based paper is uh, the technical implementation of the process, the technical implementation of the input. If we are getting data of people, how are we processing it? And that's what differs. Okay, a normal social science paper might go with a descriptive approach, might go with analytical approach. Let's say let's analyze the data, let's understand the um, distribution of tribes in there, distribution of type of people in there and stuff. But machine learning will go further technically to look at um, how can we make future predictions better? How can we automate this process? How can we accelerate the discovery of this particular thing? How can we do this? So all these are based on the machine learning pipeline. And so there's the similarity between ML projects are kind of following that pipeline, inputs, process, outputs. And the input there is data. What are we looking at? The data leakage. Okay, the data leakage. So what's in there? Then now, how is the data being explored? How is the data processed? What model are we using? And now how are we testing it? So is the data the design and the measure. And that's what I already talked about when we were looking at the crosstalk between the question and the claim. And that's similar to the machine learning pipeline. So this was just to let you understand um, the core difference similarities between the um, normal methodology review and a normal and an ML review, methods review. Okay, so it's similar, just that you're looking at specific part of the entire ML pipeline, like data leakage, the split strategy, and the compute fair baseline. Yeah. So what are we measuring? What can we say after following the ML approach to understand what is going on in the paper? Okay, we are looking at whether the metrics that they are reporting fits the decision. Okay, then the we have what we call the variance, the results, and then touch test ones. So what we're doing is that um, we are reporting, let's say AUC, we are reporting F1 score, but does the does that metric aligns with the exact context that you are looking at? For example, if you are looking at a segmentation model and you are reporting accuracy, how does it align? Okay, so you see, accuracy mostly misleads on imbalance. So it means that you have to look at maybe F1 score, AUROC, PRs, some calibration stuff, and more. So you do comparisons for this. So you compare various models with respect to that specific metrics. So okay, I have 5 papers. So each paper is using F1, each paper is using this for this particular context. So 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 you look at the similarities across all the papers. And if you have, for example, you are reading 50 papers and you understand that okay, these are following the same pipeline, and then you understand that these metrics are the same that's being reported in all the papers. Now, I want to verify, is this supposed to be so? What's the evidence between this paper using accuracy, this paper also using the same? For the context being worked on, is it right? So these are some of the errors that you should look at. Okay, yeah. So what I would end with in terms of the entire review pipeline is one, tooling. So you can read and organize the papers with Semantic Scholar, and then you also have connected papers. Then use Zotero to organize them, right? So you can read and then organize them. Then you can perform experiments with ML flow, weight and biases, and many others. Then, so weight and bias basically means um, it's a platform that helps you to introduce biases and then weights. So um, talking of the data, I want to experiment different bias levels and stuff. I want to explore, okay, the representation of various variables in that data. Then the reproducibility, you can also talk of sharing, so like getting a paper, trying to re-implement a paper, and then sharing it across. You can make it open source for others to use. So that one, Hugging Face is there, GitHub releases are there, and you have papers with code too. So if you want to understand much about how to understand papers or the entire review or machine learning pipeline papers, I recommend these resources like How to Read a Paper by Keshav. So I talked about the three phases or the three pass approach methods to reviewing paper, right? Then you can also look at data sheets for data sets. Then look at model cards for model reporting. And lastly, the beta lesson. So you can look at these approaches, and I think it will help you, to understand much about how to read papers. Then there are 3 rules that you should keep. Read to re-implement. That means that if you are reading a technical paper, think of it as at the end, I'm going to implement this paper. I want to see how the result is, so as to prove whether the evidence that has been reported is right or not, and how I can also build something novel on top of that. That's one thing. Then name the evidence. That means that every claim points experiment that will break if false. This is very strong. Every claim points to the experiment that would break if false. Then last one is beat a fair baseline. So equal compute, equal tuning, or the win isn't real. So you try and then aspiring exactly the same thing with the exact compute, maybe storage, the exact tuning parameters and all to see if the result is real or not. And now, if the result is real, can I beat that baseline? Can I implement that baseline in other context? So in machine learning summary, we read papers not to just read to prove that I read a lot. We read, understand, and then implement the approach in different contexts or in the same context. And then we try to doubt the evidence, because if that hypothesis that they've stated, for example, we have a null hypothesis and then you set an alternative hypothesis at the end, what's going to be the result? What are you getting? And what's the evidence behind that? True or false? So if I'm getting alternative hypothesis to prove that okay, the null hypothesis was right, now I want to prove that's what they are saying. I want to understand whether it's right or not. So I have to also experiment. Okay, so these are the three rules that I'm going to leave with you. Um, if you want to understand more about this, you can book me on peerbooking.live. You search for Ransford Oppond. You get more about that. But to end this session, I'll just take you through paper to repo, which is now open source. You can contribute to it if you're a developer. So you build together and then make it better. But all the pipeline that I've talked about today has been implemented in there. So it helps you to kind of understand the methodology that you're talking about in the paper, so that you won't waste a lot of hours on that. And what it does is it's rebuild the methodology for you. So it gets your data source, it gets code implementations, it creates a repository for you. You can push it to GitHub, you can run it in a terminal, you can also visualize architecture and many others. So let me quickly show the entire process. So this is paper to repo. So when you come here, you can sign in or get started. But then if you don't have, if it is your first time, you can enjoy like free trial without signing in. I think one upload. But then if you exhaust that, you have to sign in. So let me sign in. Okay. Yeah. So I've already done some reviews, so I can just use them. Good. So let's create a new replication. So you can bring a link from a research journal, research paper journal, or you can upload a PDF. So let me go to archive and then search for maybe segment anything. So this is the paper. So I can copy this link, bring it here, paste it. Okay, paste it here, and then analyze the paper. So when it analyzes it, you're going to get this. So it extracts. So what you have is this is the topic, and this is the category, image segmentation. So it will extract some information. So this paper introduces the segment anything model, a foundation model for prompt-based image segmentation. The model is evaluated on various zero-shot tasks using a newly created data set of over 1 billion masks. And so it shows the replication difficulty. How difficult is it to duplicate? Then now you can view the code. So I just want to take you through the general outputs before we go into the view code. Then it shows large data size, complexity of prompt-based interactions, proprietary data handling steps. That is the score that you are getting over there. Then it shows you the data set that you are using. So the name of the data set is the SA1B. It comprises of 11 million images, 1.1 billion masks. And because it's a segmentation model, that's why we are saying masked. Then it shows you the splits. Then the data set source, right? Then it talks to you about it, explains the architecture that they use over there. So for some specifically, it's consists of an image encoder, right? A vision transformer specifically, a prompt encoder, and a lightweight mask decoder. And it explains everything. Then how they trained the model. So the optimizer, the learning rate schedule, learning rates, batch size, epochs, so 90k iterations in here, loss, combination of focal loss and dice loss, regularizations, then the hardware that they used, right? Then the pre-processing approach, the metrics that they reported in there, then the key equations that they used over there, and some things that are missing or assumptions. So it's labels them here. Okay, so if you want, I can actually explain more about the training pipeline. So you can understand more about the training pipeline here. Okay, there's time it's like a large data set called blah blah blah, and it talks more about what is not there, like what you want to understand. Then you can also visualize the pipeline. So visualize the entire SAM pipeline. So it generates an image of how the flow works. So as if you want to maybe use it in your presentation or something, you can just copy and paste in there, or it lets you understand how the flow works. Probably you don't really understand the exact architecture in the paper, so it kind of simplifies a lot. Okay, so it's rendering the diagram. So whilst we wait, you can also now you get a repository of all the codes that you can implement. So these are kind of helping to replicate what they've done. So you can click on view code and it opens a pane like this. Yes, so this is the image that it has been generated over here. So you can add to repo. So you click on add, you can add it here. Okay. So you have an image encoder, prompt encoder, explains much better. Like not really, I'm still perfecting the image generation model, but for now it's able to simplify it as compared to all the stuff, the architecture that has been explained in the paper. Okay, then so now we have the pre-processing pipeline, you have the model, so you have image encoder, you have decoder, prompts encoder in the normal Python file. You can also get a notebook to run in Google Colab or GitHub, Cargo, or anywhere that you want to run in. Then you have the requirement.txt. That's the packages that you have to install. You have the training pipeline. So that's how it works. Now, if you want to push to GitHub, you just click on push, and then either private or public, and then you name your repository and you push it. It will create a repository and push. But before it will work, you have to connect your GitHub. So this you connect your GitHub account here by going to the profile settings and coming here. And I'm able to do a lot of replications here because of my subscription. So for now, if you want to, if you're on a free trial, you can only do 3 applications per every month. You can do full extractions. You can check out these. But then if you want to enjoy unlimited applications, there are some tiers that's affordable, right? Yeah. So if you're a team, a lab, or something you want to subscribe, there's that feature in here. And there are developer APIs that you can also use. So you can also download the course, and if you want to run, there's a container that you can run your experiments in to check the outputs. Right. So this is paper to repo, and I'm looking at implementing a lot of features, optimizing a lot of layers in there, like commercializing it too, whilst also open sourcing. So I kind of run open sourcing as a service some time ago on peerbooking. You can I'll publish a video soon so that you get access to it. But it's an open source project and also going to be commercialized. Okay, so I'm looking for contributors. You can go to GitHub, search for Grants Junior paper to repo, or just search paper to repo. You can see it. I'll send a link to you after this session so that you can contribute. So we get to the end of this session. If you have any questions, you can bring it up. Any questions? All right. So thank you very much for joining this session. It's been amazing. About 30 to 40 minutes session with you on understanding machine learning research methodologies. I believe you've enjoyed a lot and you're going to implement some of the strategies that have been talked about here. And I'm looking forward to getting all of you as contributors so that you can build a future of ML understanding together. Um, Continue to enjoy peer booking. If you want to schedule one-on-one session with me, you can just search for my name Ransford Oppond on peer booking, and I'll be glad to assist you through every meet. Thank you very much and enjoy the rest of your day.